book right there, you can get it.
Hold up.
Allison.
Wait before you start.
You
Are we
should,
good?
you should start.
All right, Super Big Productions, part 4 today. This is the force of friction.
Thought it was 3.
This is 4, sir, if you're keeping up.
I haven't.
Doing some math.
Part 4. Part 4. Part 4. Here we go, force of friction. You got this. All right,
Got it.
the force of friction is the resistance to a change in motion between two surfaces.
Static friction.
And kinetic friction.
You just want to be hurt, don't you?
The resistance to change in motion
Excuse me.
between two surfaces.
You left the E off the change.
I gotta get my child support.
We're gonna change in motion between, and I spelled two wrong. Other than that, it's perfect. Two surfaces. There you go. All right.
No.
We're in science, not a spelling bee.
All right. The resistance to change in motion between two surfaces is force of friction. So, if it's the resistance to change in motion from getting started, we call it static friction, which you'll see in your textbook.
Is this the second page of notes?
Force, friction, static, something like that. Okay?
Can you go up?
And then we have a change in motion. If it's already moving, as you already can figure out, kinetic means motion. Call it kinetic friction. And that is force of friction, K. All right. So, the resistance to change in motion between two surfaces. Static friction is change in motion from not moving to moving. Kinetic friction is when, after it already starts moving, then there's a friction between the two surfaces. So, smart class, which of those is going to be bigger? Static or kinetic?
Kinetic.
Oh,
No,
Bob.
static.
Static, because it's got to start
It's going
moving.
to be a lot harder to get it started moving than it is to keep it moving. Once you get it off the bead, so to speak, then the friction will reduce because it's already moving. So the static friction is always going to be more than the kinetic friction.
Can you go down?
And so we have a formula to represent the relationship between those two surfaces, the object and the surface it's moving on, and it looks like this. There's a ratio, and we've used this symbol right here, which is the Greek mu. Looks like a U with a tail on it. Mu equals force of friction, and that can be either one, static or kinetic, divided by the normal force, which, if you'll remember, is equal to the value of the weight.
So the normal force is just the weight.
The weight. The normal force is just the weight. It's just the opposite sign. Exactly right. In most cases, on a horizontal surface, when you get on an incline, then the normal force is a ratio to the weight, sine or cosine.
Will we be doing that later?
Yeah, we will. Just a little bit. Yes. We'll do
So
the
mu's
inclines.
change.
The normal force is always perpendicular to the surface. So on a horizontal surface, the weight and the normal force is exactly right. But as you incline it, the normal force reduces slightly, it increases with the angle. All right, there we go. So, we got this? That ought to be good.
Pause it. I mean,
That's it, we're good.